Good afternoon, good morning, wherever you may be connecting in from for our virtual event. I'd like to welcome you and thank you for taking the time to join us here. My name is Mark Coggin. I'm the Senior Director of Product Marketing within the Platform Business Unit at Red Hat. In this unit, I'm responsible for all go-to-market activities for Red Hat Enterprise Linux, our flagship product. And today, I wanted to spend a few minutes describing to you Red Hat Enterprise Linux, the original cloud operating system, and really get into the details about why we're so excited about the history that Red Hat Enterprise Linux has and why it continues to be the foundation for cloud computing, including all of its wonderful attributes, capabilities, and how it will continue to be the foundation for cloud computing moving well into the future. If you have been reading the press over the last year or even back as recently as about 5 years ago, you'll notice that many individuals have been talking about the death of the operating system. Some refer to this as the cloud killing the operating system, as you see here in picture, cited by John Stokes, published in Wired magazine in November of last year. But you can also look back as far as 2007 and hear one of the co-founders of VMware talking about effectively the VMware and the hypervisor predicting the death of the operating system. So for a variety of reasons, the operating system has been deemed to be irrelevant and will eventually die. But contrary to that point of view, what we would like to share with you today is, in fact, that the operating system is not only alive and well, but it is, in fact, the basis for the cloud. And specifically, as we are going to point out, Red Hat Enterprise Linux is the original cloud operating system. Now, one way to look at this and to maybe put forth a counterpoint to the notion of the cloud killing the operating system is to look at the growth in Linux specifically and in the operating system market overall. And going back as far as 2007 and coming forth to today, you can see that in real shipments, the operating system does continue to grow. Despite a small drop-off based on the economic constriction of 2008, the operating system has grown and has grown very, very nicely and has continued to grow across really Linux and Windows specifically. Yes, there are some operating systems that are shrinking, but overall, the operating system market and Linux specifically continue to grow share. And this data comes from IDC and is cited at the source on the bottom of the slide, and you can go and read the full report there. But this really bolsters our point that the operating system and Linux are far from dying. So I think it's helpful to take a look at the history of cloud computing and to really understand the evolution of how it began, how it's evolved, and where we sit today and moving into the future. In fact, an interesting quote that is made by John McCarthy really about 50 years ago is that computation may someday be organized as a public utility. And that's quite a prescient view of the world and how things really do exist today. Now, if you look back through the late 60s, you'll see that the ARPANET was created. That evolved and really became the Internet as we know it today. The ARPANET, of course, being initially funded through the defense agencies and government with the intent of creating highly available and reliable packet switching technologies such that networks were effectively immune to attack from a militaristic point of view. But that created the foundation for the Internet as we know it today. And the Internet and its wonderful things really became vibrant and available to consumers and professionals and businesses in the 90s. And that's really where we call the Internet age beginning. And of course, this was first and foremost a network and infrastructure behind it, but it became vibrant and accessible through the development of a browser, initially the Mosaic browser, which opened up the doors of the Internet to the user, to people with PCs and desktops initially. And that spurred a whole wave of innovation on the internet, that being what we call the World Wide Web, which is the graphically rich portion of the internet that folks access. And of course that spawned commerce, collaboration, companies like eBay, Salesforce to run your business and sales automation, Amazon as a commerce company, but then ultimately as a web services and cloud computing company, with today, as we know, EC2, Amazon Storage, Google and their services, including Google Apps, and then Force.com. So you see a very rich evolution of the internet. And guess what? If you look at these key evolutions and key innovations that have occurred, and the companies that have really made significant improvements to the internet today, like Amazon, like Salesforce, like Google, like Netflix, Facebook, LinkedIn, and even going back to Mozilla.org, as that's kind of the current view of Mosaic, and the browser with Firefox. Those organizations really all today base their existence on Linux. They were created because Linux was available to them. So again, the fact that Linux existed allowed those companies to flourish and prosper, and really allowed the cloud as we know it today to come to life. Now, another interesting trend that we see, and this is bolstered by research from a variety of sources, including the Linux Foundation, and also pointed out numerous times in the press, is that Linux is really one of the foundational elements and really integral in projects like big data and cloud computing. And really Linux is driving this with the increased capabilities of Linux around security, around virtualization. It is the foundation for these new solution initiatives, and is doing so largely at the expense of Windows and Unix, as pointed out on the slide. So we continue to see many trends. We continue to see the operating system being important. We continue to see cloud computing move forward overall, and fundamentally we see Linux as being the core foundation of all of these initiatives, moving cloud computing forward and these new projects. So if you see slide 6, you'll notice an interesting chalkboard pictogram. And what the story is intended to tell is the story of Linux, the story of the internet, the story of Microsoft, and also could be looked at as a story of cloud computing. And in effect, you've got disconnected from Microsoft, Microsoft being represented by the individual on the land, kind of oblivious, kind of safe, but isolated on an island, and then Linux, really riding the waves of the internet, as shown by the penguin on the mouse / paddleboard, riding the waves. And again, this is symbolic of Microsoft, again, being on an island, not taking some of the things going on around them very seriously. And in effect, we know through history, going back 20 years, that Microsoft really didn't take the internet very seriously initially, and then had to respond very quickly, very deliberately, to become serious with some of their product offerings, their services offerings like MSN, the browser, Windows Internet Explorer, things like that. But initially they were oblivious. Initially they ignored this trend and saw the internet as somewhat of a toy or childish. And I think they viewed Linux the same way, ignoring Linux initially, not treating it as a serious alternative to the Microsoft Windows server operating environment. But today, of course, they are taking it seriously. They're taking Linux very seriously and really enhancing Windows Server to be similar in many respects to Linux. And then you could also make the same claim about the cloud computing as well. Again, Microsoft not taking cloud computing very seriously, being late to the game, now responding, of course, more deliberately and more quickly and more urgently around their offerings. So again, this picture just shows that many of these ideas, early on with the internet and then Linux and then even cloud computing, were ones that weren't taken very seriously by Microsoft, And Microsoft, again, being pictured metaphorically on the island, oblivious, with a drink in their hand, and then thinking that these are really childish and toy-like things that weren't to be taken very seriously. Now, a couple of other things to point out. We've talked about Linux as the foundation for new solution initiatives, but let's take a look specifically at why we can make this claim. So if you look at the Linux Foundation and some research they conducted earlier this year, they show that the research suggests that 8 out of 10 clouds are built on Linux. Similarly, if you look at some of the research that was conducted by Wired Magazine, they took a survey of Amazon EC2 instances running Linux versus Windows, and they showed that Linux was twice as popular as Windows as a container image on Amazon Web Services. Similarly, Rackspace, who does report their Linux versus Windows usage inside of their hosting environments, also shows that the split is even more dramatic, and that is 3 times the number of users favor and use Linux compared to Windows. So, most people would not argue with the premise that both Amazon and Rackspace are 2 of the most notable, prominent cloud offerings and services in the world. And here, the data that we've collected, or that I should say Wired Magazine collected, really does prove out that, in fact, Linux is the foundation for these cloud deployments. Taking that a bit closer to home, you can look at Red Hat's customer references and see that many of them are, in fact, the world's most prominent cloud service providers. Companies like Salesforce.com run their infrastructure on top of Red Hat Enterprise Linux. Fujitsu, NTT Communications, Telstra, all service providers by their own right, also building out cloud service offerings on top of Red Hat Enterprise Linux. IBM with their Lotus Live offering as well. And Amazon.com, through the use of Red Hat Enterprise Linux as, available hosted images for the Amazon Web Services. Really, as we say here, top clouds are relying on Red Hat and Red Hat Enterprise Linux specifically. So let's begin to look at why we really do believe that Red Hat Enterprise Linux is the original cloud operating system, and why, in fact, today it is so foundational and critical to cloud deployments. And to look at that, what we want to do is examine a few of the characteristics that the National Institutes of Standards and Technology, known as NIST, talks about when they describe their definition of cloud computing. And we're going to dive into these in a bit more detail and kind of alter their framework a little bit, but in effect, they talk about things like on-demand capabilities, like resource pooling, like resource elasticity or rapid elasticity, the ability to measure and manage. So they talk about these characteristics and attributes that are integral to cloud computing. And these, in fact, as we're going to talk about, are really, really core to the way Linux and Red Hat Enterprise Linux is built. So let's start looking at some of these attributes specifically. So Red Hat Enterprise Linux is portable. And, the cloud promise, of course, is built on the premise that users and developers, as well as the managers of applications, have the freedom to move these applications across various types of systems, various deployment models. They can deploy them and move them from a physical system to a virtualized data center, to a private cloud within that data center, or even to a private cloud. So the portability aspect is very critical, but it also not only is important for the applications themselves to be portable, but that the programming model and the services model that they're based upon is also equally portable. And to be portable like this, it requires architectural support across the systems from various OEMs. It requires the commitment to maintaining the application binary interface that exists to the hardware level. It also includes a commitment to making the portability or a standard approach to the application programming interface so that applications built on top of the operating system work regardless. So this is all key underpinnings of why Red Hat Enterprise Linux is portable, because we achieve all this through the ABI stability, API stability, as I mentioned, through the portability across multiple hardware architectures, and really the notion of having a standard operating environment for Red Hat Enterprise Linux that allows this portability to take place. And we've talked about these attributes a little bit already on slide 11, and so I'm not going to get into some of them, but I didn't talk about the life cycle, and that's another aspect that is probably worth mentioning. You know, Red Hat Enterprise Linux comes with a 10-year committed life cycle. So that stability exists across that 10 years, which is also very important for customers who seek to standardize and lock down that standardized operating environment over those 10 years, and also be able to really, move and have the flexibility during that course of their architectural deployment, and know that it will be portable through the entire life cycle. The next slide talks about the consistency of Red Hat Enterprise Linux, and why is this important? Well, I think we've already touched on a little bit of this, but the consistency is really that you want to be able to deploy applications and web services in a cloud environment to a consistent target platform that really abstracts away the underlying infrastructure, such that it really becomes somewhat irrelevant for the user or developer or manager of those applications. So this is really critical for ISVs who want to create those applications, and ensure that for the user it works across all cloud deployment scenarios. Again, since Red Hat Enterprise Linux is the same regardless of where you deploy it, portability across the cloud is made possible because you have this consistent operating system that exists. Fundamentally, that we've been talking about this and alluding to it, but Red Hat Enterprise Linux is a platform for applications. That's what it is designed to do, to serve, and to provide. It is the vehicle for which applications are delivered to users of those apps or the services or data that are tied into those applications. Now, to do that, it requires the application development platform. It requires a runtime environment. It requires libraries, ABIs, etc. And whether you do this in a physical environment on a server inside of an operating data center, or whether you do that as a cloud service in, say, a platform as a service model, and in fact on slide 13, that's what we were describing here is our OpenShift offering, our platform as a service offering, where underneath this, and what helps make OpenShift so powerful, is the fact that Red Hat Enterprise Linux is that standard underlying operating environment, including the libraries, runtime components, and APIs that exist for it, making it, again, a perfect and suitable and consistent application platform. Next, we're going to talk about really the fact that you can automate Red Hat Enterprise Linux and you can scale as a byproduct of that automation. We all understand that one of the true benefits of cloud is that you can automate it, and you need to automate it, because as you go to do rapid and elastic provisioning, up and or down, this requires automation. It means you need tools, utilities, so that you can do the provisioning, you can do the deployment of cloud-based and virtual images, you can do the management of those images through a life cycle, and only with automation can you really do this at scale, at cloud scale. And that's a critical aspect of cloud requirements, but also a tool and capabilities that Red Hat Enterprise Linux provides. For all of its life, Red Hat Enterprise Linux has had very powerful shell scripts and command line interface capabilities. This is one of the overall capabilities of Red Hat Enterprise Linux that system administrators, developers, and users love. And through this, you can do remote management. You can do the scale-out provisioning that's being required, really to build out and provision in a cloud large-scale mission-critical applications. And this has really made Red Hat Enterprise Linux the popular choice it is for those cloud-scale deployments. Next, we'll talk about this notion of pooling resources and why this is so important. Virtualization is fundamentally the foundation for any cloud infrastructure, because it really gets to how resources are provisioned, managed, and deployed on the underlying physical infrastructure. And to do this, of course, you need a leading hypervisor capability. And inside of Red Hat Enterprise Linux is Red Hat Enterprise Virtualization and the KVM hypervisor. And through this, you can do the work needed to provision the compute resources in a virtualized environment, and really creating the flexibility and agility needed that the cloud really does require. And of course, KVM is supported and managed by hundreds of companies in the Open Virtualization Alliance, and it's just a critical open source initiative that we're one of the leaders of. And we talked a little bit about the standards basis, and also we'll add to that the openness of Red Hat Enterprise Linux. And that presents several interesting byproducts that are very important. The operating system has to be open, and that the hybrid cloud really needs to be standards-based, open, and ubiquitous. And that we would prove through Red Hat Enterprise Linux that this model works using a community, using a distributed collaboration approach, and an open standards basis does work to create one of the best and leading platforms in the world. You could look at OpenStack as well as another project that's gaining significant traction in the industry with just incredible uptake in the last 6 months in terms of committers, commits, companies involved. So Rackspace is behind this, NASA's behind this, Red Hat is behind this, but OpenStack is a very viable example of an open project that has delivered excellent results and proves, and soon will prove to be, the leading platform for virtualized management. And really, when you look at the words here from Gary Chen, who's one of the managers, an analyst at IDC, he's showing that 80% of enterprises cite this lack of standards as a challenge in them being able to embrace cloud computing. And so that Red Hat specifically, and the way we approach and why we believe open source is not only a development framework, but it's a way to embrace and drive industry standards, is so critical and is really the most important aspect of cloud adoption. And we at Red Hat call this open hybrid cloud. And going on to slide 17, what we'll say here is that this is a way to manage and measure those resources that we were talking about. And this again goes back to the NIST definition of cloud computing. But why is it important to be able to manage and measure resources? Well, we give the tools and capabilities with products like Red Hat Network Satellite, like resource management through Linux containers and cgroups. The ability to really not only manage the resources and provision them to a compute and resource level, as done with cgroups. You can allocate system resources like CPU memory and network I/O to processes running on a system. Linux containers is also a lightweight way, or a low footprint way of creating a multi-tenancy approach to your system. All of these are important vehicles for how you build out a cloud architecture. And then ultimately using products like Satellite, Red Hat Network Satellite, to actually manage, measure, and in the case of if you want to even get into chargeback mechanisms. These are all vehicles that exist today with Red Hat Enterprise Linux and through the capabilities and tools around it, but also are critical to anyone undertaking a cloud architecture. And we've also mentioned the flexibility of Red Hat Enterprise Linux. Doing a strong cloud architecture requires not only a flexible code base, but the ability to modify and tailor the packaging. And a Red Hat Enterprise Linux does provide all these capabilities. So there is the ability to architect the flexibility at the operating system level, but there's also the need to build up a solution that's customizable. And things like SE Linux and being able to put in kernel-based security at the right way around specific security policies is critical. Being able to architect Linux containers with policies for resource provisioning and management, all very important tools in the ability to tailor and make a flexible platform. This is really, and then of course we talked about OpenShift a little bit, but the fact that OpenShift can run in a multi-tenant model not only at the hypervisor but also at the operating system level. So this flexibility and this ability to customize is also really a critical capability. But ultimately, even when you've done this, you're still left with a consistent operating environment that runs across physical, virtual, and cloud environments, and ultimately you're still able to kind of have the best of both worlds. And then finally, on slide 19, what we see here is, really in summary, the statement that Red Hat Enterprise Linux is the cloud operating system. And it provides many benefits and attributes that we've described. It provides the ability to deliver any application, anytime, anywhere, and the portability for that. It provides the consistency to support ubiquitous, not only deployment, but also development. Also, implied in the any app, anywhere, anytime. It provides the application platform and the runtime environment that is required for a cloud operating system. You can automate it. You can automate Red Hat Enterprise Linux, which is critical for your ability to scale in the way that cloud scale deployments require. You can use the virtualization capabilities of Red Hat Enterprise Virtualization and KVM to pool resources and do that kind of resource pooling that is also critical for a cloud deployment. You've got the openness and the standards-based approach, and you're able to measure and manage these resources as we described through the tools and capabilities provided. And finally, it's flexible and customizable not only at the operating system level but also at the architecture level for the solution itself, such that the right cloud solution can be deployed. And fundamentally, these do all tie together. They support each other. For example, the openness and standards-based approach ties and does support the notion of ubiquity. It does support and apply to the portability attributes. So these two all tie together. But fundamentally, when you lay them all out, it does make Red Hat Enterprise Linux the cloud operating system. And as we said, this is proven out by customers, by press and analysts who are studying and analyzing this set of dynamics, and just the market trends overall, where Red Hat Enterprise Linux is becoming the basis for these new age deployments like cloud, and helping companies. And you can go to redhat.com and see many of the customer references that exist, including the ones that I mentioned earlier in the presentation, and see that they are, in fact, doing leading edge things, creating cloud services, cloud offerings, cloud capabilities, whether they are for their internal IT and strategic direction, or whether they are for services or applications they're providing as a service to the external market. But they're doing this on top of Red Hat Enterprise Linux. So again, we know that the cloud demands the choice and flexibility, and because of this, we believe that Red Hat Enterprise Linux is today the cloud operating system and will remain the cloud operating system well into the future. So given that, I'd like to thank you for joining us today for this virtual event, and we encourage you to visit redhat.com and collect further information, and also feel free to reach out to us directly with questions and other feedback you might have. Have a good day.